So, in these questions, we're giving you all the forces explicitly, but sometimes you won't. You'll just have a problem that you have to solve involving motion of a body, and you have to think, oh, weight is going to be acting on that. Gravity is going to be pulling it downwards. And sometimes there are some clever tricks. So, suppose I have a body hanging. Oh, which way did they do it? Doesn't really matter. They all do it the same as them, though.
A body hanging.
A body hanging from the ceiling from two strings.
Okay. Yeah.
Why not? Think a picture frame hanging on a wall from two wires.
That's a lot less gruesome.
Oh, right, that's what you're worried about. Okay, right, that's what you're worried about. And we are going to call this, so this is 25 degrees, and this one is 40 degrees.
Does it matter where they're attached to?
You tell me, does it?
I assume so.
What will it change if I change where it attaches here?
The angle?
Of the object?
Oh, where it attaches.
But it's not going to change its position. It's not going to change its acceleration. Only its rotation. So, when solving these problems, we simplify the model. We make assumptions. We assume that the object is a point mass with no horizontal vertical extent at all. It's all acting at the point where the centre of mass is. Exactly the same thing as you do in physics. It's a point mass. And we just ignore all that. Now, if you want to do that, you can. It just involves rotational mechanics, which used to be in the old physics syllabus like 2 syllabuses ago. It is not in the current syllabus. So, you can do the physics for that, but we don't here. So, this is acting. You have to sit there and go, I haven't got all the forces yet. Because if there was a force acting in this direction, that string is pulling it in that direction, and this string is pulling it in that direction, it would be going upwards towards the ceiling, but it's not. Why? Because gravity is pulling it down. There is a third force acting, which is the weight force. So we're going to call this, that was clever, wasn't it? F1 and F2, and they are vectors. And then I need the weight force. Now, you can write little w, or you can go straight to mass times gravity. Remembering gravity is a force, so it's actually a vector. I happen to know that it is 10 kilograms. I'm going to make my box a little bit bigger and write 10
It could just be dense.
kilograms in it. You can write it somewhere nearby, it's good enough. How do I work out how much tension force is actually in those two wires? So one thing you can do is this kind of stuff we did before. You can have two forces, you can add them up. There's actually 3 forces here. You know what this one is. It's 9.8 times 10 kilograms. And you can add them up. You'll get simultaneous equations. You have to solve the simultaneous equations. Sometimes it gets a bit messy. You can do that. If you get stuck, you can do that. There is, however, a quicker way.
Splitting it?
No, even easier. Yes?
Is the person not mean the upward force you have to be equal to gravity?
Yeah, so that's how you get one of your 2 equations for simultaneous equations. But there is an easier way. This object is hanging. It's not moving. We say, in the words of the syllabus, it's in equilibrium. If it's in equilibrium, there's no net force. These 3 forces exactly balance each other. Another way to say that, which we've long at the start, they add up to 0. If I have forces, go to the model. If I have vectors that add up to 0, that means where I start, and I do all my vectors in order, I end up back where I started. So I can take these forces and go, force 1, force 2, weight force, and I have to get back to where I started. Because it's in equilibrium, only because it's in equilibrium. Now I have to be careful to work out the angles where I want them. This angle is 25 degrees. That 40 is actually, this angle here is 40 degrees. And the weight force is exactly vertical.
Where's 40 up there?
Because it's the angle between force 2 and horizontal.
Yeah, okay.
Can you see how I got that diagram and where I put the forces? Because that's what you have to be able to do to use this method. You know, take your diagram and go, the three forces together have to add to 0, but they're vectors. So you draw them in a triangle and make them go back to where they started. Then you go, well, this one's 25 degrees from horizontal, this one's 40 degrees from horizontal, and then you solve the triangle. It's now just a geometry problem. If this is 40 degrees, that's a Z. Can you see the Z? Remember doing the Z
Yes.
a long time ago? So that means this is also 40 degrees. So this angle in here is 65 degrees.
Mm.
Oh wait, I actually know something. This side here is 10 times 9.8, 98 newtons, right?
Mm-hmm.
And I know more. If this is 40, this angle must be 50 degrees. And if this is 25, then that's 25 down the bottom, which means this is how big? How big is the angle inside the triangle? If this is 25, 65 degrees. A, B, oh wait, I had, no I didn't, that was a different problem. C. And A, B, C. I'm just labelling them because I'm about to use the sine rule. If I want to find B, B over sine B, and I know A over sine A. Let's use the sine rule. So my length B must be, that was not intended,
That was not.
must be A, that's 98, over sine 65 degrees, times sine B is 50 degrees. Calculator time. Do the same thing to work out length C. Go.
60. 80.4.
Let's see. 80. They did not get
82.8.
82.8.
I believe.
Wait, force 1, force 2. Which one did they work out? That's what I'm trying to work out. Okay, so 80, they got 82.8. What did you get?
82.8.
Was that-
82.8.
Oh, I did 80. Okay, 82.
I did it wrong.
Whoops. Okay, 82.8 newtons. Do the same thing to work out little c. That, by the way, is the length of force 1. C on sine C is, oh, I have a choice. Which one should I use?
A.
Because,
You didn't work
that's
it
what
out.
else answer. Because,
You didn't work it out. So it's
correct,
completely right.
from the question. Good, good, good. A on sine A. So C is 98, whoops, on sine 65 degrees, that was messy, times sine 65 degrees. That's the length of force 2. That's the magnitude of force 2. You're not bothering to calculate this morning. 98?
That was easy.
Yeah, look.
You just cancelled them out.
And I've worked out the tension in both the wires.
Cool. That was so easy.
Much easier than simultaneous equations, right?
Yeah.
Much easier. So sometimes you can find a quicker route. If it's an equilibrium, which the syllabus says you have to be able to work out these questions in equilibrium, then you can just do this. Find a way to draw the forces so they end up where they started. So sometimes you can use the sine rule, sometimes you might be using the cosine rule, sometimes you might be using trig, but find some way to solve this and you can work out your lengths.